Good morning and welcome to the video for Wednesday. This will be our last lesson of the year. This is going to be the culmination of everything that we've worked on in this chapter and highlight the reasons why we learned statistics in the first place. Today's lesson is going to be working with misleading statistics. So let's go ahead and take a look at our Unlock the Problem for today. Mr. Owen wants to move to a town where the daily high temperature is in the 70s most days. Here are the results of our statistics, and we want to figure out if this is going to match what Mr. Owen is looking for and explain why or why not. We can go ahead and use these values and plug them in to answer different questions. Is the average temperature in the 70s using the statistics, and we want to figure out the distribution of data. Our minimum high temperature is going to be 62 degrees, which is going to be lower than 70, but not considerably. For instance, I live in Ohio, where in the winter the average high temperature on a good day might get up into the 40s or 50s, but more often than not is going to be at or below freezing. Our maximum high temperature is going to be 95 degrees, which would be considerably higher than 80 degrees. And the median of our data set is going to be 69 degrees. And that means at least half of the days, roughly, are going to be less than or equal to 69 degrees. So again, we're really close to being at that half or a little bit over for being 70 degrees, but it's not going to match what our person would be looking for in this problem, even though it's close. One of our takeaways from this is, even though they represent the word mean in our problem so that we can look at this particular number, what they would normally say is, oh, well, the average is about 72 degrees. When we look at the statistics for it, it really is an average, but it doesn't represent the fact that the average temperature on most days is not going to be 72. It's not even going to necessarily be in the 70s because it could be considerably higher or considerably lower. So this would be an example of why a statistic might be misleading. Not because someone's trying to intentionally lie, but they are choosing the particular method of center that best represents what they want to share about the data. Let's go ahead and take a look at our next problem. So we are looking for a car dealership where we would have a wide range of cars for sale at many different price ranges. So many different cars at many different price ranges. As we look at these numbers, we can already tell before we start plugging any of these numbers in to make a box plot that many of these numbers were looking between 50 and 65,000, and we do have cars that are at the lower price range, but not enough to really suggest that this might match what she's looking for. Let's go ahead and plot these points on a box plot to get a good look at our data. So I'm going to go ahead and take the lowest price of 12,000 and put a dot roughly in the center between 10 and 15,000. I am going to put a dot for our lower quartile of 50,000, which you can already tell is a drastic difference. So this is the low end of our most consolidated set of data points. Our median is going to be 55,000. Our upper quartile is going to be 60,000, and our top end is going to be 65,000. Price ranges are going to be mostly consolidated in this range, which suggests that we are not going to be in a situation that this is going to be a place that she would want to shop at. Our follow-up question, what would the box plot look like for a dealership that does meet these requirements? The biggest thing would be this particular range here. The interquartile range needs to be much larger. The book kind of suggests that it could be as much as $10,000 or $15,000 different or lower to meet that range. That doesn't mean our entire interquartile range needs to go all the way down to here, but we definitely need more variety. Probably at least another 10 to 15, maybe even 20,000 would really show that there is a wide variety of cars for sale at a wide variety of prices. Now let's go ahead and look at our share and show. And what they suggest is to go ahead and circle important facts, get the organization for the information. Now, For instance, number 1, we are going to have that organized by the kind of follow-up questions or statements that they want us to fill in. Then we're going to choose a strategy for how we are going to represent everything and check to make sure that we answered all the parts of the question. For number 1, Josh is playing a game at a carnival. If his arrow lands on a section marked 25 or higher, he wins a prize. Josh will only play if most of the players win a prize. The carnival worker says the average is 28, and that's using the mean. The box plot shows other statistics about the game. Should Josh play the game? First thing we want to do is go ahead and take a look at our median. Our median is sitting right on 20 points. The median is going to be the center value of the data. We could also use the word middle. So at least half of the value scores are less than or equal to 20. So let's go ahead and take a look at the rest of our statistics. We do have a range that extends all the way from, let's say, about 43 or 44 points down to 10, and most of the scores are concentrated between 50 and 30 points, which suggests maybe the mean is going to be inflated some by these higher scores. So I would argue that the median is probably a more accurate representation of what we're working with. And even our interquartile range of 15 suggests that there may be a wide variety of scores for this particular game. Both of those things together indicate to me that he should probably not play this game. Number 2 is going to be a follow-up question. What if a score of 15 or greater resulted in a prize? If a score of 15 or greater resulted in a prize, he should definitely play this game because the lowest end of our most concentrated set of data points would fall in a score that would result in a prize, and then we go up from there. Now let's take a look at number 3. A store collects data on the sales of DVD players each week for 3 months. We have our values here. The manager determines that the data has a range of 62 players and decides that the weekly sales were very inconsistent. We want to figure out whether the scores were actually inconsistent or not and explain the answer. One of the things that we can do is go ahead and take these numbers and make a quick box plot. So let's go ahead and do that real quick. All right, here is what I came up with for my rough estimate for a box plot. And we can use this information to figure out something really important. While we do have a value that kind of sticks out down here toward the bottom for our minimum week, and that represents that there was some inconsistency, our main set of values is going to be really close to our maximum as well as really close together. We can take a look at our interquartile range by doing 72 minus 58, and that would give us an interquartile range of 14, which I feel more accurately represents what we're working with here. The range being so spread out doesn't necessarily mean that we had inconsistency on average. That means there was some inconsistency, but on the average, it looks like we stayed in a pretty reasonable range for weekly sales. Let's go ahead and take a look at number 4. This one looks a little bit odd to me because it doesn't involve statistics, at least not in my mind. We are looking to find the perimeter of a yard that is 21 feet by 18 feet, and we want to translate our feet to yards to figure out how many yards of fencing material he needs. If we go ahead and divide by 3, we would get 7 yards for this measurement and 6 for this. So we can simply do 7 times 2 and 6 times 2, add those together to get the number of yards. So we'd have 14, 20, 26 yards. Number 5, we're back to a question that does work with statistics. Susanna wants to buy a fish that grows to be about 4 inches long. Mark suggests she buys the same type of fish he has. He has 5 of these fish with lengths of 1 inch, 1 inch, 6 inches, 6 inches, 6 inches, with a mean length of 4 inches. Will this work? So think about that. We could represent our fish by using the mean, we could represent the lengths of the fish by using the median, and we could represent them by using the mode. So if we use the mode, we would have one set of numbers that we have 3 times. So Our average would actually be 6 inches if we use the mode. If we use our median, it's going to be our third value, which would also be 6 inches. And the mean length would be 4 inches. So to me, that would suggest maybe she doesn't want to buy this type of fish. It looks like it's either going to be much more or much less than an average length of 4 inches. And if we're really going to be picky about making sure the fish ends up being about 4 inches long, we don't have any representation in our data values that suggest that if she buys the same type of fish, that it will end up being 4 inches long, even if we can say that we have an average of 4 inches. Let's go ahead and take a look at number 6. This may not work with statistics in the same way that we have been looking at because we are looking at a pattern. I want you to take a few moments, look at our chart, and see what the pattern might be. Pause the video if you need to, and when you're ready, we'll talk through what the answer should be. All right, assuming you did that, our pattern, we are alternating between counting up 2 and counting backward 1. If we continue this pattern on week 7, we would go down to 4 stamps collected, and then on week 8 we would go up to 6 for week 8. So 6 stamps for week 8. And the explanation is talking through this particular repeating pattern. Number 7, the data set shows the number of hours Luke plays the piano each week. Luke says he usually plays the piano 3 hours per week. Why is that statement misleading? Well, you can go ahead and look at the numbers. This 10 hours in a week is a huge outlier. If we wanted to look at the mode as a measure of center to show how many hours per week he usually practices, we would get 2, and that would be a really good way to do that. If we were looking at the median, we would be looking at the 4th number out of 7, and so that would be 1, 2, 3, 4. So again, the median would be a much better representation of the center instead of trying to use the mean. All right, so let's take a look at our homework problems for today. We are going to take a look at number 2, number 4, number 6, number 1 and 2 on the back for my Risen Christ students. I will talk through all of the problems. For number 2, we are just looking for the mean. You're going to go ahead and add everything up, divide by our number of data points. They want us to construct a box plot, so you're going to want to find the median as well as the upper and lower quartile, and then that will allow us to go ahead and answer the rest of the questions. For number 7, give an example of a misleading statistic and explain why it's misleading. I will let you choose whatever you would like. We can find plenty of examples in this lesson or other lessons throughout the chapter that suggest that if we try to represent something a certain way, that it would become a misleading statistic. Number 1 on the back, we just want to find the range, so you are going to be subtracting your highest value minus the lowest value to calculate that. For number 2, you're going to find the interquartile range, so you're going to need to put these in order, find the median, the upper and lower quartile, and then that will help you answer that problem. For number 3, we are removing the outlier and then finding the median. That lowers us down to 5 data points, so that should be pretty easy to calculate. For number 4, I had to manually draw in the box plot from the teacher's edition. We're looking for the interquartile range for that, so that should be easy to calculate. And our last question, number 5, we have team scores. We want at least a score of 20 to be considered a good score. So what measure of center would be best for Erin to use with these scores to motivate her teammates? So that concludes everything we are working with for today. I hope everything makes sense. I'm going to be doing a lot of editing in this particular video to kind of piece things together and shorten the video while trying to give all of the relevant details that we need to talk about. If you have any questions after watching this and you're one of my students, please reach out to me on Google Classroom or reach out to your classroom teacher if you are not. The homework video for this will be coming out on Thursday morning, and that will be the conclusion of our math videos. There will also be a video for our virtual field day, which I am currently in the process of working on at the time of recording this particular video. If you end up watching the intro to that, you will notice that I'm wearing the exact same shirt that I'm wearing right now. I'm recording several days in advance. So please feel free to join us for that. Have a wonderful time. All of my Risen Christ students, I do miss you a lot. I wish we could spend the rest of the year together in the classroom instead of what we had to do, but we're making the best of a bad situation. I wish all of you the best of luck as you go on to middle school and on to bigger and better things as you get older and get into your teenage years and eventually graduate from high school. It's been a blessing to have you all as a teacher, even if I haven't gotten to spend as much time with you the previous 2 years as I have this year. Stay safe, stay well, do your best in everything that you do, and enjoy the summer for what it is. Have a wonderful time to relax and refresh from a very difficult year and a different year than what we normally expect. And also take advantage of the extra videos and so forth that I'll be doing for your class to talk about things that you'll want to keep in mind as you get ready to go into 7th grade. So blessings on your summer. Best of luck to all of our graduating 6th graders that are moving on to middle school, and I will see you in the next video.